Hi there. In this video I'm going to be solving an example on vector projection. So here's the exercise. It says find the distance between the line y equals 2x and the point 6, 2. So if this is the line y equals 2x over here, and this is the point 6, 2, I want to find the distance between them. And whenever we say we want to find the distance between a point and a line, we mean the perpendicular distance, which is the shortest distance between the point and the line. So I suggest you pause the video and try and solve this problem yourself, then come back and see how I solve it. Okay, so if I draw a vector here pointing from the origin to this point, this vector will be 6, 2. And if I draw a vector here lying onto this line, well, think about it. This line is y equals 2x, which means if I move 1 unit in the x direction, I have to move 2 units in the y direction. So if I wanna draw a vector that lies on this line, could be 1, 2, 2, 4, and so on. 4, 8. So I'm just gonna pick the vector 1, 2. That's one of the vectors that lie on this line over here. Now if I project this vector 6, 2 over this vector over here, I'm gonna get a new vector that starts from the origin and ends at this point. Then I can find the coordinates of this point, and using the formula for the distance between 2 points, I can find the distance. Okay, so I created a vector from the origin to this point. I created a vector that lies on the line y equals 2x. Then I'm gonna project this vector onto this vector over here to find the blue vector that will tell me the coordinates of this point. And let me remind you for the formula to find the formula for vector projection. So if I want to project vector A onto vector B, this is gonna be A dotted with B hat, all multiplied by B hat. So this vector over here, I don't know, let's call it vector C. Vector C is gonna be 6, 2 dotted with a unit vector pointing in the direction of 1, 2. So this will be 1, 2 divided by its magnitude. Because remember, a unit vector is equal to the vector divided by its magnitude. Okay, and all of this multiplied by this same vector over here. So let me simplify this. If I take the square root 5 outside, I get 6, 2 dotted with 1, 2 multiplied by 1, 2, and square root 5 times square root 5 will give me 5. So if I do this dot product, I get 6 plus 4 multiplied by 1, 2 over 5, which gives me 10 over 5 times 1, 2 equals to 2. So this just scales the vector to be 2, 4. So I found out that the blue vector over here, C, is 2 and 4. Which means that this point, since this vector points from the origin, this means that this point over here has the coordinates 2, 4. Now I have the coordinates of this point, and I was given the coordinates of this point, so we need to figure out the distance between 2, 4, and the original point, which was 6, 2. So using the formula to find the distance between 2 points, it's the square root of the change in the x coordinates, which is gonna be 6 minus 2 squared, plus the change in the y coordinates. So this is gonna be square root of 16 plus square root of 16 plus 4, which is gonna be square root of 20. And that's your final answer. You can simplify it even more if you want to, but that's just fine. So this is the distance between the point and the line. If you have any questions, leave them down in the comments section below and I'll be more than happy to answer them. Thanks.